I'm John McQuay with 8541 Tactical, and this is Mail Call Mondays, the show that answers your questions about precision rifles, optics, and equipment. Welcome to another Mail Call Mondays, and I'm sure you're noticing first off the bat, the beard is gone. Well, it's getting a little warm here in southern Indiana. Time to shave the beard. I don't need it to protect my face from the cold anymore. And to be honest, the wife was getting a little tired of it. So away it goes until next fall, and maybe we'll see it have a reappearance. But anyway, on to the reason that you are tuning into the show. Now, last week I left you guys off with a botched ladder test. We went out and we shot a ladder test with our new 260 at 300 yards. And we had a bunch of failures that day. We had the target board blowing over. We had our target camera fail. So what we ended up with was this shot group here, and really no way to correlate the shot holes to the charge weights that made them. So it really didn't help us out. And of course we were using about a 1/2 inch aiming point, and with Mirage at 300 yards and a 15 power rifle scope, we were kind of having some problems picking that aiming point out as well. So just really all over, it was a bad test. Well, we went back out and we shot our ladder test again, and this time we set up a camera downrange that actually worked, that actually recorded what was going on. We used a 1.5 inch aiming spot at 300 yards, so about a 1/2 MOA aiming point, which was significant. We were able to really get a nice hold right on the center of that with our reticle. And we fired one shot each from 39 grains to 44.5 grains. We allowed approximately a minute of time to go by between each shot to try to normalize the temperature of the chamber. Now still, first shots we're firing were a cold chamber. The final shots that we were firing were on a fairly warm chamber, but I wouldn't say hot to that point. And we were firing the cartridges rapidly, so as soon as we chambered up that cartridge, we weren't letting it cook in the chamber. We're getting it in there, getting a good sight picture, and firing that shot to make sure that we didn't get too much heat soak affecting our results. And this is what we came out with. Now, real sidebar real quick. If you're really concerned with heat affecting your shot groups, or you're doing this on a really hot summer day or in the middle of the cold winter, then what you can do is do 3 separate ladder tests, 3 separate target boards, and on your first one you'll go from low to high and stop at whatever charge weight you feel is the limit of pressure. And then on the next test you're going to start with that charge weight and go down until you hit the bottom. And then on the final target board, again, you're going to start low and work up. And this way you have an average, and you can watch the results correlate between the different target boards, and you can be sure that heat is not vastly affecting your results. Now, as we look at our shot group here, we got back to the shop and we took a picture of it, and then we replayed the video from the target camera, and we marked where each of the shot holes correlated to what powder charges. Now, I did this on our photo editing software. I took a picture of the target board and then edited it. You do not need to do that. If you've got a camcorder, you can just shoot the video and then you can write the numbers on the target board. I didn't want to do that for here, so I can show you some things with it. But that's really the quickest way, and that's the way I've done it in the past. Now, when you look at this group, the overall group is just a little larger than 1 minute angle at 300 yards, which is excellent in my opinion. It means this is going to be a very consistent rifle with charge weights ranging from 39 grains to 44.5 grains. They still all grouped within just a little over a minute of angle. So I was really happy to see that. But then when we started playing this back, this is a really good example of a ladder test, because what you see is right down here at the bottom, our first charge of 39 grains is actually this shot hole here, and then we went 39.5, and then we went back up to 40 up here. I'm looking at my key here. 40 is up here, and then 40.5 comes back down here. And what we're seeing here is a scatter node. Those shots are just impacting wherever. It's not a tight group. It doesn't correspond really well to the charge weight. To explain a scatter node, the best way I can explain is when you fire this cartridge, it causes a shock wave to ripple through the barrel steel. That shock wave travels at the speed of sound. When the bullet starts out of the case, it is not traveling at the speed of sound yet. It takes it a little bit of distance for that bullet to get up to muzzle velocity. When it exits the muzzle, it's traveling several times the speed of sound. But back here, it's really not. So that shockwave overtakes it and runs down the barrel, and it hits the muzzle. And then when it hits the muzzle, it doesn't have anywhere to go. The shockwave is reflected back. And at the speed of sound, that shockwave bounces back and forth between the muzzle and the chamber until it diminishes. When the shockwave runs through the barrel, it's causing that barrel to open up and contract because we're working with a tube. So it causes the rifling to get looser and causes the rifling to get tighter. What we want is we want that rifling to be as tight as it can be in the last couple inches of barrel when that bullet exits. That way the rifling has the best grip on it. It stabilizes the bullet as it exits out. What I believe we're seeing in scatter nodes is that muzzles opening up, those bullets really are not tracking as well as they can out of the muzzle, and they're just flying wherever they want to fly. Now, as we come on up in here and we start getting up into 41, 41, 41 and a half, 42, 42 and a half. I mean, when we get up here to 41 and a half, 42, and 42 and a half, we're getting into just this little shot group right here, and it's just about a quarter MOA. So we have almost 2 grains of powder difference, and we're still grouping within a quarter MOA. Now we're in an accuracy node where those shots are coming together. Then as we come up further, we get all the way up to 43 and a half is this last shot hole up here. Now, when we get past 43 and a half and we get to 44 grains, we're starting to go down again. 44 and a half grains, we're down again. So what's going on here? It's kind of counterintuitive because you would think as the powder charge increases, the muzzle velocity increases, you'd think that your shots would rise. Well, muzzle velocity is one component of it, but the other component of it is barrel whip. That barrel is actually flexing up and down as you're firing that bullet. And as we get faster, the bullets are leaving on a more upward climb. Then we hit the apex of that whip. It can only whip so far before it comes back down. Now it's coming back down as the bullets are leaving. So we get this wave, this up and down on our ladder test, and that's what we have here. It goes up and it goes down. So when we look at the ladder test and we go to interpret what charge we want, we've got a couple of things that we can look at. Now, if I was going for just sheer accuracy at 300 yards, I would probably pick 42 or 42 and a half, because right there, we're just at the peak of our accuracy. We're about dead center of that accuracy node is what it looks like. So if you fall off a little side of the other, you could even go a half grain one side or the other, and this rifle is still going to group those shots right together within a quarter-minute angle at 300 yards. That's stellar accuracy. I don't think anybody can complain about a tactical rifle that will do quarter-minute angle at 300 yards. Well, this is not a 300-yard rifle. We're not shooting 300-yard bench rest. We're not just worried about that accuracy. We're worried about accuracy at 1,000 yards, because really that's where this cartridge shines. If we look at it, 43 and a half was our target. If we look at the difference between the 43 and a half charge weight and the 42 and a half charge weight, there's about a half-minute angle elevation difference between those two. We are also getting that bullet to leave at a little bit higher angle with the 43 and a half. So that means that we're going to take a little bit less to zero at that distance. So taking those things together, I'm really still looking at 43 and a half, especially since when we look at the difference between 43, 43 and a half, 44, we're still within a quarter-minute angle at 300 yards. So you wouldn't be wrong to pick 42 and a half. I just want to pick 43 and a half because I'm getting a little bit more velocity. I'm staying in that high BC area. I'm going to get a little bit better performance downrange, and I'm going to get a little less wind drift because of less time of flight for the wind to affect the bullet. So that's why I'm picking 43 and a half. But again, 42 and a half grains with the ladder test that we ran here is going to give you good accuracy. It's going to give you good performance. So you wouldn't be wrong to choose that. There is a lot of seeing pictures in the clouds when you're reading a ladder test. Now at this point I want to bring up something that was brought up on our Facebook page when we posted a picture of this ladder test that we ran. There was a gentleman that got on there and complained that I was running too coarse of a test, that when he tests his loads, he does it in 1/10 grain increments, and he does it at greater distances. Well, let me first of all tell you that there is no wrong way to do a ladder test. As long as you are doing it in a safe manner and you are gaining the information that you desire for your rifle, then you're good to go. The reason that I do a half grain ladder at 300 yards is because I believe that's the best compromise between powder and bullet expenditure and information gained. I do not work with lab quality equipment here. My scales are not calibrated to be under 1 grain. And I really honestly don't know what kind of fluctuation is. My scale reads out to 1/10, but that is the limit of where it reads to. I don't have the next decimal place to be able to tell how close to that 1/10 I am, or if I'm actually really 1.5 or if I'm all over the place. What we are looking for here is not bench rest quality loads. We are not trying to go for world record bench rest rifles. We are looking for a rifle that is going to be consistent in a wide range of weather conditions with no sighters allowed, shooting from ginked up positions at steel. Very seldom will you really have a paper stage that's going to be the deciding factor on winning or losing a match. Guys have been wanting to throw in paper stages where they do cute things like shoot the playing cards. That's cool, but that's not the majority of what we shoot at these matches. So we're looking for sub-minute angle accuracy, but we're looking for resistance to change. We're looking for a very consistent load. And for me to get a consistent load, we need a wide separation in these charges to be able to see those nodes expand and contract on our target board downrange. So that's why I stick with half grains, and that's why I stick with 300 yards. Now you can go out and do a ladder test at 1,000 yards. You're just gonna have to make sure you have a really big target board so that the wind blowing those bullets horizontally will still all impact on your board, and so that when you get that vertical separation because of barrel whip and because of velocity, that you're still impacting all on the target board. Because when you start slinging bullets off your target board, it doesn't do you any good at all. So you have to weigh those factors out, plus the available range that you have, and decide what the best thing is to do. Now I would not suggest doing a ladder test like this at 100 yards or in with a rifle of this quality, because you're just going to get a ragged hole that's not really going to tell you a lot. You need to start pushing it out at least to 300 to be able to get meaningful data. So that's my reply to why go with half grain over 1/10 grain. Now we've verified that 43.5 or even 42.5 would be a good charge weight to go with. So the next thing that we did is we went out and we loaded up a bunch of cartridges, new brass, new bullets, etc. with 43.5 and tested it downrange, and we got some nice about half MOA groups at 100 yards. So I know 43.5 is going to work. Now again, if you're doing bench rest type stuff or you want that razor's edge accuracy, you probably need to do your ladder test with fire formed cases. Go out and shoot about 10-15 cases with your starting charge to fire form them to the chamber, go back and next size them, and then load them up with your ladder test and do that, and that will give you the most accurate results. With the chamber in this rifle, I don't think we're really going to see a vast difference in our velocity between fire form cases and regular new cases. So that's why we didn't go ahead and fire form them ahead of time. Again, another step. We're expending powder, we're expending bullets for a very, very incremental gain in accuracy. I don't think it's worth it. If you do, go ahead. I'm not going to tell you you're wrong. So once we get those out and we shoot some fire formed cases, we're going to confirm the accuracy of 43.5 grains. I'll confirm it at 100 yards, and then we'll punch that velocity that we get, the muzzle velocity that we get from that, into our ballistic calculator, and we will verify that as far out as we can shoot. That way we make sure all the information is tracking correctly. Now if we get a deviation in that information, then we need to see if the deviation is because of the muzzle velocity or if it's because of the ballistic coefficient of the bullet. Depending upon where you're getting that ballistic coefficient, sometimes manufacturers inflate those claims as a marketing tool. So if it's not an actual tested BC, if it's a marketing BC, then you might be a little dubious of it versus your muzzle velocity. If you're using your buddy's borrowed beat up chronograph and things aren't tracking, then maybe the chronograph is suspect, and maybe you want to start tweaking that muzzle velocity to see if things line up before you start messing with the ballistic coefficient. So that's where we go on that. One comment that I'll make also that we got a lot of discussion on was when we use the magnetospeed chronograph, that actually attaches to the barrel of the rifle, and it does have the possibility to affect the harmonics, which is a large portion of your ladder test. So depending upon your barrel, it may or may not affect it. You may want to consider using the chronograph to shoot a ladder and just get your velocity, and then taking the chronograph off and shooting a ladder to get your pattern down range. That may be a good way to get over that if you're using a magnetospeed chronograph. Now what we saw with this rifle, I shot 2 groups with the magnetospeed on and 2 groups with magnetospeed off, and we got the same point of impact, the same group size. We had no variance with this Remington varmint weight barrel and the magnetospeed chronograph. So this rifle is fairly resistant to that, and I think that goes back into the consistency of the rifle overall. So just another thing to bear in mind. That's about all we have on this. This has been a busy last week. We went down and we shot the Woody's Designated Marksman match down in New Hill, North Carolina. We shot some footage with that. We went down there and rocked that with the Mega Arms Ma 10 project in 308. My partner was also shooting a Mega Arms Ma 10 in 308 with a little bit longer barrel, and we had a great time. This is the first time that we shot a match of this format. It's really time-based, not accuracy-based. In most of the precision rifle matches we're at, you have a par time and you can't exceed the par time, but you try to use all your par time to get the most accurate shots off. Well, the way the Woody's match works is your score is time-based. So if you can shoot the stage in a lower time, you get a higher score. And then your misses add time to the score, and there's no round count on it. You can shoot as many rounds as you want to burn down range at those targets, as long as you get in your allotted time, because when time's out, time's out. There's also, the partners are switching positions or switching roles on the clock. So it was really an eye-opener for me and my partner Nick Samet. We went down there, we shot it, and we had a great time, and we'll do a full after-action report on that. It was excellent, well-run match, a different format, and we really enjoyed it. We finished 20th out of 70 registered teams, so you know, I think we did fairly good for being thrown into that and not having shot that format before. Targets were from approximately 150 to about 550, 500 yards, somewhere in there. So it was an intermediate range, and it was really something that once we got done shooting it, we saw how it really is, it favors the gas guns. I really think gas guns will work better at that kind of format, but we saw a bunch of bolt gunners out there too. So look forward to our full after action report and our web write-up on that. Now, if you guys have any questions or comments on our ladder test or why we did things the way we did, please leave them in the comments section below or send them to us on Facebook or Twitter. And if you've liked the video, make sure you like, share, and subscribe. And until next time, get out and shoot!